Assalamu alaikum warahmatullahi wabarakatuh. This is problem 5.32, grade 11 advanced physics. In this situation, we have a father who pulls his son whose mass is 25 kilogram and who is sitting on a swing with ropes of length 3 meters. Now take a look at this picture in here. The kid is here now, okay? He's sitting on the rope, on the swing, I'm sorry, and his father will let him go so that he will move until he went back to this position. So we can assume initially he was here, he was pulled back to this situation, and then he moved to this point. Now the ropes make an angle of 33.6 with respect to the vertical. So this angle theta, we know it to be 33.6. He then releases his son from rest. So at this point he was resting, he was not moving, so the initial velocity is 0. And then he, due to of course the gravitational energy he gained due to this height, he will transfer all of this gravitational potential energy into kinetic energy so that he will go back to his initial place in here. What is the speed of the sun at the bottom of the swinging motion? So he was here and he moved all the way to here. What is the speed at this spot or at this place? Now look, this is a very simple indirect question where we have gravitational energy transferred into kinetic energy. To take a look at it, we know that this is the initial place. He was here, his father was holding him at this place, and then he let him go so that he will end in here. This is the final, okay? This is the final spot. Now what you need to know in this question, and this is the only trick in this question, is that these lengths, this height h, this d, and the length of the rope, how can we use all of these so that we can calculate the gravitational energy and the kinetic energy? Now before we go on, let's try to analyze this picture in here. Now since it is the same length, look, if you take a look in here, just change the color. Good. So you know that the rope will have the same length whether he is here or here. Of course, you have the same length L. So all of this is L, of course, right? So this L, the length of the rope, is D, this distance plus the height. Again, he was here, he moved to here, then he was let go to come back to his position. Okay, so it is the same length, it makes sense. So the first equation we can write that this length L is equal to the distance D plus the height h. What we care about actually is this height h because we need to find the gravitational energy, okay, using the height h. Now another equation which is really good for us, and that we can link all of these three numbers together using the angle theta. If you take a look at theta, you see that cosine theta is equal to d over L. Now we know this using a right triangle theorem. Look, this is our right triangle. Let me change the color one more time. Yeah, purple. I hate purple, by the way, but okay. So here it is, and this is our right triangle, of course. Okay, so given this right triangle, look at theta. You can say clearly it says that cosine theta is d over L. Okay, and these two equations actually we can use them to link h together. Now let's substitute for each d with the using this equation L. Okay, so going back to here, we can say from the first equation in here, we can say that d is equal to L minus h. Okay, this is an L. Next, we can say that cosine theta is equal, instead of d, just write L minus h, okay, over L. So I took this d, L minus h, and I plugged it in here in the cosine theta. Now let's rearrange this equation so that we can find the height h in terms of L and theta. Now look, because we know L, the length, 3 meters, and we know the angle theta, we need everything to be in terms of L and theta. So rearranging this equation, we can say that h is equal to, let's say, cosine theta, sorry, this is L. It's equal to, I will bring an L here, so you have an L, and then you will say minus L cosine theta. Okay, this is L again. Or this can be written as L multiplied by 1 minus cosine theta. I took this L out so that you can easily view this equation. Now this is a really neat and good equation in here. It's L multiplied by 1 minus cosine theta, one more time. Okay, and this is h. Now this is a very important equation. We will use it in order to solve the question. Okay, Now let's do it. Now look how easy things now are. Initially, you only have the gravitational energy. You know that UG initially is equal to m, the mass, g, the gravitational field, multiplied by the height h. Again, what is h? H is L multiplied by 1 minus cosine theta. Of course, there is no initial kinetic energy because he was at rest, so 0. And here, look, assuming that this is the ground, assuming that he went back to the ground, he touched the ground, so that there is no final energy in terms of gravity, but there is what? A final kinetic energy. Again, all these type of questions are very simple questions. You need just to understand the picture you have. You need to understand the trigonometrics and how to use the angles given to you. So 1 over 2 mv, let's call it v final square. Now let's do these two together using the conservation of mechanical energy. Given that there is no friction, delta me should be equal to 0, so that ug initial was all transferred into Ke final, and let's write these two equations in a good way. So what is UG initial? One more time, mgh, okay, which is equal to, instead of h I will write L multiplied by 1 minus cosine theta. So this will be mg L 1 minus cosine theta is equal to the final kinetic energy 1 over 2 mv squared. Now there is a really cool thing here if you paid attention. Look, in both sides you have mass m. So you can actually take out the m in here and take out the m in here. Even though that it's given to you in the question, you can use it easily. Look, you have the mass to be 25 kilograms, but still you don't need it. Even if you're not given the mass of the object, you can simply find the final velocity of it. This is really important in all of gravitational potential energy being transformed into kinetic energy without friction. Usually, you will not need the mass. Okay, given to you in the question or not, you don't need it. A lot of students will stuck in here. They're saying, okay, I have g, I have theta, I have L. I need to find the velocity, but what about the mass? I don't have the mass, so I can't solve this equation. I'm stuck. No, most of these scenarios you will be able to take out the mass from both sides. Okay, good. So now let's go ahead and do it. So now we're done with this equation. G, which is 9.81, of course, multiplied by L multiplied by 1 minus cosine theta. I know this looks like a stupid L, but this is my best, is equal 1 over 2v square. Use your calculator or do it by hand, plug in the numbers. It's very easy to find that the velocity will be 3.13 meter per second. Again, I don't pay much attention to the significant figures, rounding, and stuff like this, but this is a really good answer in terms of 3 significant figures. Okay, so again, the boy was here. He was released from this point. Once he touched this point again, once he's at, let's say, 0 height, he's at the level of the ground, he will have velocity of 3.13 meter per second. Thank you very much and see you inshallah in another video. Assalamu alaikum.